People love capturing moments, and the quickest way is by taking photos. Samsung's camera app offers the best results with features people love like real-time HDR. While these features used to be exclusive to the camera app, today everyone gets exposed to the colorful features with the Camera SDK. This is Kim, and welcome to a brand new episode of Samsung Developers. The Camera SDK puts the power of Samsung's camera into everyone's hands with all the features we'll discuss in this episode. As a developer, your applications become more exciting to use with all the cool effects ready to be shown off. Don't worry about any complicated code. The Camera SDK offers added features on top of the existing Android Camera API 2, which give you easy-to-use, fast-performing APIs for new image processing for your app. Have fun building camera apps which use features like HDR, low-light photography, panorama, and much more. But before we get to the features, let's first take a look at the architecture of the Camera SDK. The Camera SDK architecture consists of three major parts, namely Applications, Camera API, and Android Camera API 2. The Camera app and the app you will build with the Camera SDK sit on the applications level. The Camera API extends to the Android Camera API 2 with the camera, processor, filter, and image packages. All these sit on top of the Android platform. Now that we've seen how it all works together in the architecture, let's have a look at all the features the Camera SDK has to offer. Camera SDK brings several features into your applications. With that, it's best to check their availability first. To do that, the isFeatured-enabled method is used. This returns a Boolean value depending on the accessibility of the feature. The parameter needed when calling the method is only the feature type. The feature types defined in the camera class are the following: S-Camera Processor for the availability of the S-Camera Processor, S-Camera Filter for checking the filters, and lastly, S-Camera Image for image processing. With the Camera SDK, you can now implement special features of the Samsung Camera app such as the following: fast autofocus based on face, live HDR, which you can use to preview the natural image on the display, the OIS or Optical Image Stabilization, which aids shaky camera shots and improve image quality, also different preset metering modes like center, matrix, and spot. The S-Camera Processor allows the creation of a single image after capturing and processing multiple images, or from a continuous stream of data like a camera preview. It comes with a processor manager which handles the available processors, namely HDR, low light, depth of field, panorama, and effect. First is the HDR processor. This creates a high-definition image from a set of 3 images captured with different exposure values. You can also get 3 images captured within the exposure range you can set. Next is the low-light processor, which is an image enhancer for images which were captured under dark environments. It takes multiple images captured at the same exposure as input and combines them to remove noise and create a single enhanced photo. Next on the processors is the depth of field. Now this refers to the area in front and behind the object in the image that is focused, meaning all other areas are blurred or out of focus. Depth of field is used to create a dramatic effect in images, and the Camera SDK supports 2 types, shallow and deep. Shallow is for the closer range subjects, and deep extends from a little beyond our subject to very far away. Another one is the panorama processor, which lets you capture landscapes by capturing multiple images and guides with the capture direction and stitching the final image. Once the capture starts, the panorama processor can send messages to assist in capturing up, down, left, or right. Last is the effect processor. This is special because not only does it let you put effects captured images, but even on live video recording. The effects you put on images and video are called filters, and there are already 25 included in the SDK that you can use. Now let's move on to images. The Camera SDK offers great performance in image processing because it supports high-quality images. The S-camera image class has very large image buffers, whereas bitmap doesn't support higher image resolutions. You can save the images as JPEG or as RAW, and it supports color conversions to formats like RGB24, NV21, and YUYV with NV21 as the default format. Let's take a look at the Camera SDK's image processing core, which supports 7 transformations you could use. First is the Sobel filter. It is an image processing technique to create an image that emphasizes edges and transitions. Next up is the median filter, which is an image processing technique to remove noise. Another capability is contrast enhancement. This is pretty straightforward with the developer giving 2 parameters, namely contrast factor and pivot, which represents the color intensity. Next on the list is equalize histogram. This is an image intensifying adjustment technique where gain and contrast can be seen. A more extreme transformation to the image is warp affine, where the image can be rotated, scaled, and skewed as needed by the developer. Last of the transformations is spatial filter. It is an operation where a mask is applied to the image, which could be Laplacian, high boost, Gaussian, or others. With all these great features ready to be showcased, please remember that the Camera SDK requires Android 5.0 Lollipop, API level 21 or above. Also, supported functions might change according to the hardware performance. Now let's take a look at the sample app that comes with the SDK. Notice that the libs folder has 2 jar files. Aside from those 2, add all of these native libraries, the ones with the extension .so, to the JNI libs folder. Always include them in every project you make, so you may use the SDK. Your project build target should be Android 5.0, API level 21 or higher. Next, let's add a permission to access the camera since this is a camera app. Add another permission to use the filters. Lastly, a permission to initialize the SDK. The Camera SDK sample Java file will be our entry point. Here, we let the user choose among the list of features, then call a separate class. Now from the list, we'll go through the HDR processor feature. Before we start, let me just remind you of the distinction between live or real-time HDR as to the HDR processor. Real-time HDR is a hardware feature, which means it only works when the right hardware is present on the device. On the other hand, HDR processor is a processor feature that captures an image and does a post-process to produce pictures with varying exposures. The HDR processor feature is not dependent on the availability of the correct hardware. First, we need the basic variables needed for the sample app. Basically, these are the classes included in the camera package. More will be encountered as we move along. Next are the camera states, which many functions in our app will refer to from time to time. The camera states currently available are idle, preview, wait autofocus, wait auto exposure lock, take HDR picture, and closing. The HDR session capture callback, which extends S-camera capture session.callback abstract class, is then declared to track the progress of a capture request submitted to a camera device. The callback is invoked when a request triggers the capture to start or when the capture is completed. Also, we can see that the autofocus and auto exposure state are checked if finished processing before the camera takes the picture. As discussed earlier, HDR collects camera shots with different exposures. The image reader on image available listener is the one that collects the images and puts them in an image list for processing by mProcessor. The mProcessor has a method called request multiprocess for handling the collected images. The decode to bitmap method supports the preview of the images. So when the camera's HDR processor is called back, it saves the resulting image to a JPEG file and displays the input images as a bitmap. The S-Camera HDR processor event callback is defined and its purpose is to receive results from the HDR processor. It has different methods which manages the life cycle of the HDR process. On the onProcessCompleted method, the app will save the image result into a file, then decode it into a bitmap that will be shown into a dialog for display or preview. There's also the HDR process's onResume method to initialize the camera state. During that stage, it also checks the camera's features to notify the user that certain features are not available with their device. Similar to the HDR process's onResume method, the onPause method of the HDR process is also set to close the camera and release resources. Moving on to the OpenCamera method, it first acquires camera characteristics. Then it acquires the auto exposure step. This is the smallest step by which exposure compensation can be changed. Since the camera's output image can be larger than the display resolution, it has to define the maximum preview size. Next, the HDR processor is invoked by calling the initProcessor method. It sets the correct parameter for the processor, then initializes it. The HDR process callback is also set inside the initProcessor method. A preview session is also created. This method creates an S-Capture request builder for preview with output target. Once the preview has been configured, it calls the start preview method, which has a session capture callback. To get sharper images and take HDR pictures, there's a need to define lock autofocus and unlock autofocus functions. Additionally, the lock auto exposure method is created to help focus on the present image exposure. The autofocus and auto exposure are constantly being toggled on the process of taking an HDR photo. In order to get correct image previews and results, we need to set listeners and functions to correct the image based on the present orientation. Now, the image saver must be configured for writing the image into the phone of the user. You will need an output stream for this. It will also use a file name which uses the current date and time. In this example, the input images were also placed in a dialog box for preview. With the Take HDR Picture method, 3 images of varying exposure are taken for collection. These are defined as a long exposure, medium exposure, and short exposure. It sets the order by defining what's next and then takes the photo. Now that's just one of the few features of the Camera SDK. Here we have the camera app. Our usual setting include flash and the timer. What's new here is the HDR feature. You can have it on auto mode, on, and off. The other feature is the effect, where you can choose an effect for your images and even for videos. Now with the Camera SDK, we've incorporated those features in our own app. Let's try single first. It just captures a single image and saves it to a file. Next we have effect. Like in our camera app, this adds a certain effect to our image depending on the filter we choose. High Dynamic Range or HDR, which we explain in the code walkthrough, takes 3 images of varying exposure values and shows a preview to the user. Low light enhances the dark areas of the image. In the preview here is like the before and after parts. Now let's skip to filter. It's just like the effect, but here you preload an image, then apply the chosen filter. You can process it as a bitmap and save it as is as a file. The same process is involved in the image processing accelerator. You choose an image from the gallery, then choose a process you want the image to go through. From the menu, you can use it as either JPEG or RAW. Let's wrap up today's episode on the Camera SDK. Features that make the Samsung Camera app amazing are now available through the Camera SDK. The Camera SDK provides developers with APIs that enables creation of feature-rich camera-based applications. It extends and builds on the Android Camera API too. Remember to utilize the isFeatureEnabled method to check the features available to your device. With Camera SDK, Samsung special features such as fast phase autofocus, real-time HDR, OIS, and preset metering modes are made available at your disposal. The S-Camera processor makes great photos through the Processor Manager, which handles HDR, low light, depth of field, panorama, and effect. The image package offers high-performance capabilities for image transformation, color conversion, and large files handling due to the larger image buffers. Lastly, the SDK requires Android 5.0 or higher, and functions may depend on hardware performance. That concludes the Camera SDK. Get exposed to Samsung Camera app's colorful features. If you have any inquiries, please post your questions in the official forum at developer.samsung.com. Also, don't forget to give a thumbs up on this video and subscribe to the Samsung Developers channel. Thanks for watching and see you on the next episode.